All right, so this is Mr. G. This is a test video from one of the problems from your practice assignment from last week. This is the airplane. This is the airplane problem from the linear equations unit. So here's the question. It says, after traveling for 4 hours and 1,800 miles, an airplane begins a steady descent. When it begins descending, its altitude or its height is 33,000 feet. After 8 minutes, it is at 17,000 feet. Answer the questions to write a function that models the plane's altitude. All right, so before we get into the problem, let's do a little bit of a recap. This is a topic that we covered while we were in class together, but that was some time ago, so I'm going to go quick little recap. All right, so the ordered pairs x, y represent points on a line. So a linear function is representing hopefully a straight line. Straight line is just a collection of points, and those points are represented by the ordered pairs of x, y. Linear functions can be represented in words, so like through a story, through function notation, through a table form, and graphically. During this problem, we're going to, since the question is asking us to write an equation, we're also going to write an equation, so which would be function notation, and then we're going to graph it, so it'll be represented two different ways. Functions can be represented by the equation y equals mx plus b. This is called slope-intercept form. Remember, this is called slope-intercept form. So the y in this equation is represent the input. This is basically what is our answer is going to be. M is representing the slope or the rate of change. So when we have a line, depending on how steep that line is, that's going to be represented by our slope. X is always going to stay the same, so that's going to be called our output. B, or our y-intercept, is where the line crosses the y-axis. It's also known as the initial value in our word problems. All right, let's move on. So these are the types of slope. Remember, if we go back, slope is represented by m in our slope-intercept form. So if it is a positive slope, if it rises going from left to right. If it falls from left to right, or if it goes down from left to right, that's a negative slope. If it's just a horizontal line, that'll be 0. If it's a vertical line, that'll be undefined. You won't have too many examples like these in your notes, in your quizzes, in your assignments on Apex. So we're going to focus on the positive slope and the negative slope. All right, so let's reread the question. It says, after traveling for 4 hours and 1,800 miles, an airplane begins a steady descent. When it begins descending, its altitude or its height is 33,000 feet. After 8 minutes, it's at 17,000 feet. Answer the questions to write a function that models the plane's altitude. So the first question is, how quickly does the plane descend? Or in other words, what is the rate of change or the slope of the plane's altitude? Show your work. I am going to, let's see, start with red. So after traveling for 4 hours and 1,800 miles, the airplane begins a steady descent. So for 4 hours, this plane has been going straight, and hopefully the plane is going a little bit straighter than that. Let's try that again. So the plane is flying on a straight line, and it's been going this way for 4 hours. And this is 1,800 miles. So it begins a steady descent. Descent means it's going downwards. So it's getting closer to the ground. So it's beginning altitude is 33,000 feet. After 8 minutes, it is 17,000 feet. So if I start at 33,000 feet, and after 8 minutes, I'm at 17,000 feet. I can start by finding out the difference of those numbers. And 0 minus 0, 0. 0 minus 0, staying the same. I can't subtract 3 minus 7, so I need to take one of these away. 13 minus 7 is going to give me 6, and then 2 minus 1 is going to give me 1. So I know that the plane descended from 33,000 to 17,000 in 8 minutes. So my plane descended 16,000 feet in 8 minutes. Now the question is asking, what is the rate of change? So how many feet did the plane descend in 1 minute? So to do that, I can just divide 16,000 feet that we descended by 8 minutes. And 8 goes into 16 twice, minus 16. I'm left with 0. I can drop this 0 down so I can just keep adding my zeros. So, sorry about that. So I've got 2,000 feet in 1 minute. So that answers my question. How quickly does the airplane descend? So my rate of change is, I'm going down, negative 2,000 feet per minute. So my rate of change, my slope, or my m, is equals to negative 2,000. So that's my answer for number 1. So it says, when graphing the descent of the plane, what would the starting value for its altitude be? So let's reread the problem. It says, after traveling for 4 hours and 1,800 miles, an airplane begins a steady descent. When it begins descending, so its starting value, so it's starting right here at 33,000 feet. So when graphing the descent of the plane, my starting value is going to be 33,000 feet. So if this is the ground, 33,000 feet would be somewhere around here. So my starting value is going to be 33,000. Okay. So my starting value is also, if we go back, my initial value is also my B. So I can go B, it's going to be 33,000 is where I'm starting from. So it says, write a linear function in y is equals mx plus b, which is slope intercept form, that gives the plane's altitude after it begins its descent. Use x to represent the time in minutes after the descent starts and y to represent the plane's altitude in feet. So if I go back, I remember that my m was negative 2,000, and then my b was 33,000 feet. So my m is 2,000 feet per minute, and then my b was 33,000 feet to start with. Now I just need to plug these into my linear function. So if my equation starts off as y is equal to mx plus b. My m is negative 2,000. So y is equal to negative 2,000 x plus my value for b, which is 33,000. And this is my final answer right here. So my answer is y is equal to negative 2,000x plus 33,000. So is there any information given in this problem that we did not need to write an equation for the descent? If so, what unnecessary information was given? So I'll rewrite our equation. So we've got y is equal to negative 2,000x. Let's erase that. Y is equal to negative 2,000x plus 33,000. So if this is our equation in slope-intercept form, we don't have 4 hours in here. We don't have 1,800 miles in here. So it doesn't necessarily matter. So if we're writing an equation to figure out the descent, it does not necessarily matter how long the plane was flying and how far the plane was flying before it started descending. So when you get on the airplane, you start on the ground, you take off, you fly some, and then you start to descend. Well, the question is not asking about any of this information right here. So we don't know where we took off from, we don't know where we're going. We do know that we started at 33,000 feet, and after 8 minutes, we were at about 17,000 feet. So we know how fast we're approaching the ground, and that is all the information that we needed. If you have any questions, please email me, pgarner@ccboe. You can also put comments or questions on the team's assignments, and I will answer them as quickly as I can.